Hey, good day, future engineers. Welcome sa ating discussion. Today, we'll be talking about improper integrals. Now, in the last time, we talked about the improper integrals with infinite integration limits. This time, we'll talk about improper integrals with infinite discontinuities. So, sa maning kuan, infinite integration limit. So, again, no, kaning infinite integration limits. The first type, the case one we have, katong either the upper approaches positive infinity, the lower approaches a negative infinity, or both of them is approaching infinity. That is the infinite, the integration limits. Now we have the infinite discontinuities. So summoning infinite discontinuity. An infinite discontinuity, wala na padayon ang atoang integral. Nga naman ni discontinue siya. It is discontinuous at a certain or a specific points. So when will this happen? First, let's define the improper integrals with infinite discontinuities. The first one, we have if the function is continuous on the interval a to b and has an infinite discontinuity at b. So, yung gingon diri is that continuous siya from A to B, pero at B, yung upper limit, infinite is continuity. Therefore, the integral of f of x dx from A to B is just equal to the limit of the f of x dx from A to C as C approaches B. So may pasabot aning negative sign diri. As C approaches B from the left. So, unsa man ni siya? Unsa may representation ani nato? Let's say we have a graph here again, no? So, mas masabtan man nato na with the graphical representation. Let's say we have a curve here. And then at this point, say this is A, and then we have a B here. And then at this point, the function f, so all throughout no from A to B, continuous the function f, but at B, there is an infinite discontinuity. So we have also pasabot, we have an infinite discontinuity at the point B, and we write that as the limit of f of x dx from A to C as C approaches B from the left. So what is the C? C is any point from A to B. Let's say this is our C. And then ganun as C approaches B from the left because this is B and then approach siya kang B. C is approaching B from the left side. This is the left side of the B. Sa second pod, if the function is continuous on the interval from A to B and has an infinite discontinuity at A. So here, si A ang na infinite discontinuity. So let's say same yapon nga ko ano sample from mas masabta nato. We have a curve also here, no? And then here we have B. And then let's say at A, there is an infinite discontinuity of the function f. So we have a function from A to B, continuous siya, walay putol, but at point A, there is an infinite discontinuity. So we have here that is just equal to the limit of f of x dx from, again, naanaputi C to B. As he approaches A, sa maning positive. Kung negative is from the left, A is from the right. So again, C is any point from the interval A to B. So that is, let's see, C is a point here. And then C is approaching A from the right. So as you can see, C is approaching A from the right because nasa sa right side ni A. So the first one is the upper limit has an infinite discontinuity at the upper limit. The second one, there is an infinite discontinuity at A. Now, the third one, the function f is continuous on the interval a and b, except for some c and a in the interval a to b at which the function f has an infinite discontinuity. So sa third one po is that you also have a curve. Let's say this is the b and say this is the a. At a and b, there is no infinite discontinuity of the function. But on a certain point, let's say c, at this point c, nga na ay infinite discontinuity. So what happens is that mura siya sa third type na to ganiya, no? Nato siyang tungaon from a to c. We have the integral of f of x dx from a to c, and then plus the integral of f of x dx from c to b. So we have two parts. We have the c approaches a from the right and c approaches b from the left. Okay, para mas masabtan na to, let's start with our first example. So for our first example, we were asked to evaluate dx over cube root of x from 0 to 1. So in the first type of improper integral, no, ang iyang upper and lower limit is either nga naka infinite kwan siya, infinite limit, or both has an infinite limit. This one is that na gyud siya yung upper and lower limit, 0 and 1. So what will happen next? Kano sa man siya mamong infinite discontinuity. If you notice no, nasa denominator si x. At any number nga x, there is a value except at x is equal to 0. If x is equal to 0, the function will become 1 over 0. That is undefined. So at 1 over 0, there exists an infinite discontinuity when x is equal to 0. So sa ato ang upper and lower limit, makita nato nga si lower limit di ay ang ato ang infinite discontinuity. So we can rewrite this one as the limit of the integral of x raised to negative 1/3 dx. So ato siyang rewrite in exponent form from a to 1, or let's say c, pwede na a, as a approaches as 0 from the right. So tanawon nato diri, no, this is the graph of the function. You have the lower limit nga 0, upper limit here is 1. And then as a approaches 0 from the right. So from the right siya, because this is there is an infinite discontinuity at this point. And then as c as a value or a number approaches 0, muna siya to ang gina-consider. Okay, let's solve this one. The integral of x raised to negative 1/3. So that is just equal to, by power rule, no, that is just equal to 3/2 times x raised to 2/3 from a to 1, as a approaches 0 from the right. So this is a, no. From our definition earlier, this is katong equal na to sa c. So don't be confused with that one. Now, padayon lang tag-solve, that is equal to the limit of, we have here the 3/2 times 1 raised to 2/3 minus 3/2 times a raised to 2/3. A approaches 0 from the right. So we will have the limit of 3/2 minus 3/2 as a times a raised to 2/3 as a approaches 0 from the right. Now, as unsa may value nga or number nga itong ibutang with a as it approaches from 0 from the right. So you write very small value kanang close kaayo ni 0. Let's say 0.00000001. Let's say that that is our a as it approaches zero from the right. So as a approaches from the right, this function here, value here, approaches to zero. Therefore, our final answer is equal to 3 halves. So si 3 halves na lang mabilin. Since we have a particular answer, therefore the improper integral converges. So take note now that the first type of improper integral kato infinite integration limits, dali ra kay siya makita because the lower and upper limits is approaching infinity. This one, you need to examine first. Kung asa mag discontinuous or there is a infinite discontinuity sa ato ang function. So the first example is there is an infinite discontinuity when x is equal to 0. So that is the lower limit. Okay, next for our second example, we're asked to find the integral of dx over x cubed from 0 to 2. Again, with this one, kanusaman siya mo, there is an infinite discontinuity. When we have an x is equal to 0, diba, the function 1 over x cubed becomes 1 over 0. That is undefined. Therefore, same yapon with the first example, there is an infinite discontinuity at 0. So we rewrite this one into limit form. That is the limit of dx over x cubed from c to 2 as c approaches a 0 from where? Again, from the right. Okay, we have here the 0, and then from 0 to 2, we have here from 0 to 2 as per the graph. And then c is any point here, and it approaches 0 from the right of 0. So that is just equal to the limit of, by our power rule, that is 1 over negative 1 over 2x squared. So we've eliminated from c to 2 as c approaches 0 from the right. So that this is equal to the limit of, we have the negative 1 over 2 times 2 squared plus 1 over 2c squared as c approaches 0 from the right. It's equal to the limit of, we have a negative 1/8 plus 1 over 2c squared as c approaches 0 from the right. So sa may next na button, let's assume a value very close to 0. Let's say our c is 0.000001. And as you can see, that the more nga mugamay si denominator, mas dana mo anam kadako si value. Kani siya nga function here on this side. And at any value nga c, this value here, or the function here, also increases. Therefore, our integral of dx over x cubed from 0 to 2 is approaching positive infinity. Since there is no a particular solution, then therefore our curve is diverging, or it diverges. Now for a third example, we have the integral of dx over square root of x times quantity x plus 1. Now, as you can see that on this example, again, there is an infinite discontinuity at 0. So that is an improper integral. But also notice that the upper limit is approaching positive infinity. The upper limit is approaching positive infinity. So this is considered a doubly improper integral. Diba? So, di lang siya yung na isa-isa lang ang ga-exist. Pwede siya magduha-duha. That is when, so this is a combination of our type 1 and type 2 of improper integral. The first, because it is an infinite integration upper limit. And the second one, it has an infinite discontinuity at x is equal to 0. So, since this is a double integral, uh, ato ni siyang tungaon into 2. Or we'll have a breaking point. That is from 0 to a number and from that number to the positive infinity. So, for convenience, let's say our breaking point is katong c is just equal to 1. Para mas dali. So, we will have integral of dx over square root of x times x plus 1 from 0 to 1 plus the integral of dx over square root of x times x plus 1 from 1 to positive infinity. So this is for kuan no para mas dali siya nga kuan pag-solve because this is a double improper integral. On the left side, we just write this the limit of dx over square root of x times x plus 1. Let's say the lower limit is the a to 1 as a approaches a 0 from the right. And then the other one will have the limit of integral of dx over square root of x times x plus 1 from 1 to b as b approaches positive infinity. Okay, this one, this is an example of a, again, the inverse triangle. So the integral of dx over square root of x times x plus 1, pwede tawad okay, we just write its final solution for that one. That is just arctangent to arctangent square root of x. So we have evaluated from a to 1, where a is approaching 0 from the right. And then on this side, we have the limit of 2 arctangent x, arctangent square root of x, to be evaluated from 1 to b as b approaches positive infinity. Now for the first part, we will have 2 arctangent x, 2 arctangent square root of 1, that is just 1, minus 2 arctangent of a. Let's say square root of a. As a approaches 0 from the right. And here we have the limit of 2 arctangent b minus 2 arctangent 1 as b approaches positive infinity. As you can see now, natin 2 arctangent 1 here, positive and a negative 2 arctangent 1. So that cancels out. Now how about this one? If we have an a, as a approaches 0 from the right, now let's say our a is 0.000000001, a very, very close number, no, sa ito 0. The value here approaches also to 0. That is very small. So let's say that's equal to 0. And how about this on the right side? As b approaches positive infinity, let's say our b is, let's say our b here is 999,199,000, etc. And then times 2, you will get a value of a pi here on this side. So overall, we have a 0 here because it cancels out, and then you have a 0 here. Then we will have our final answer as pi. So therefore, our example 3 is improper integral with a limit. Then therefore, we say that it converges. So this is the curve, and then the area of the unbounded region is this one, the pi. So nga ato mo na siya ginabalik-balik ng area of the unbounded region because as discussed na po from the previous discussions nato, to get the area beneath the curve, that is just the integral. We just get the integral of the function of that curve from the given upper and lower limits. Now, to sum up our discussion for our improper integral, we have two types of improper integral. The first one, we have the infinite integration limits. It is when either the upper limit is an infinite is approaching positive infinity, or the lower limit approaches the negative infinity, or both the upper and lower limit approaches the positive and the negative infinity. So this is the type 1 of the improper integral. So what we gonna do if the upper limit approaches positive infinity? We just write that as the equal to the limit of the function f of x dx from a to b as b approaches positive infinity, or if ang lower limit approaches negative infinity, same concept to the first one. And then next na to button is that we find the integral of the integral on this side, and then we apply the upper and lower limits. Now for the upper and lower limits, we just apply katong dako kayo nga value, no? And then analyze what will happen at differing values as it approaches infinity. Is it constant, or does it approaches to zero, or does it approaches to one? And then we'll have our value. Same also with the third one here. So on the third one, like, if there is an infinite limits on the upper and lower, na lang tayo ginatawag na breaking point. Let's say kanisi C. Why will have a breaking point para mapareha siya ni we have here the case 1 and the case 2. An eye breaking point sa ato ang pag-evaluate sa improper integral. And then if there is a limit, if the limit exists, therefore the improper integral converges. If there is no limit, no, if no limit exists, then our improper integral diverges. Keep in mind, no, that the improper integral is a definite integral, but such that ilang upper and lower limit is that it approaches infinity, or it has infinite discontinuities in the upper and lower limit or within its point. Now, our second type of the improper integral is that it is an integral with infinite discontinuities. So the type 1 is that si upper limit na to is the infinite discontinuity. So we have a function continuation from A to B, but ang upper limit is that is in the infinite discontinuity. That causes a 1 over 0, di ba, sa tong function as our example. And then second type na to is that the lower limit is giving us an infinite discontinuity. So mo lang yapon to siya, no, we just rewrite this one here as the if the upper limit is approach is the infinite discontinuity, we just rewrite that as the limit of the function f of x dx from a to c as c approaches b from the left. Katong as explained ako last time. And then if the lower limit is the infinite discontinuity, then we just rewrite that as the integral of the limit of the integral of f of x dx from c to b as c approaches a from the right. Again, ang c here is the any point, no, as it approaches the upper limit, or in this one the lower limit. And the third one in the infinite discontinuities, we have the ang a ug b is continuous si function, and then pero the thing is that there is infinite discontinuity within the function. We call that our point C in this one. So itong buhaton is that guragay po nato siyang tungaon the infinite discontinuity C atong point nga naka-discontinuous sa ato ang function will be our breaking point with this one. So ato siyang tagsaan, and then we applied the concepts we have here and also here. And the same thing also if we have a limit, the improper integral converges. And if the limit does not exist, then therefore the improper integral diverges. So that's all for our improper integral. That is just very basic, no? Dali, lagi ka na siya ano na ninyo, improper siya if either the lower and the upper limit or both of them is approaching the infinities, or a point in it, it's either the lower or the upper limit, or within the interval, gives the function, katong graph na itong gibuhat, there is a function, uh, there is an infinite discontinuity in the function at a certain point. So that is our two types of improper integral. And I hope you learned something from this discussion. And please feel free to message me for any questions.